Okay, so we're going to start talking about some applications of right triangles here to start Unit 3. So hopefully there's some application here, and these Chapter 3 examples are fairly maybe linked a little more to your experience, and therefore gives them a little more context and a little bit easier to work through here. So the first one is, obviously right triangles can be used in real-world situations in construction, surveying, navigation. In air and sea navigation, bearings are used, okay, if you ever hear that. Oops, wrong thing there, sorry. Bearings are used, okay, to specify a location from one point to the other. Clockwise angle from north, okay, in the line of travel is called the course, all right, of an airplane. The clockwise angle from north and to the line of sight is called the bearing, all right. So we'll not harp on that too much, but it'd be good to know, I think. So it says how to write the bearing down here. Let me just go through these quick. If the acute angle is measured from the north side of the north side south line, then you write the north first, and if the acute angle is measured on the south side, you write the south first. Second, write the measure of the angle, and if it's acute measured on the east side, you write the east last, and if it's measured on that, you write the west last. So let's see if we can just apply that quick just out of maybe interest. All right, so the bearing from O to D. So if you look from here, right, so I'm looking from O. Oh, wait, sorry, wrong thing. I'm looking from O to D. Okay, now first of all, that's on the south side, right? So I'm going to write south. All right, so basically on the bottom half of the horizontal line there. And then I look and I say, okay, what degree is given here? So I have it from here. From south, there's a 27-degree line. And which way does it lean then from there, sort of left and right? It leans to the right, which would be east, okay? Now, if we do it that way, what would be the degree here rotating around this way, all right? So if you look at it here, south 80 degrees, sorry, south 27 degrees east, right? If you come from the north, okay, you could also come around this way here and say it's 153 degrees this way. Okay, again, if we go clockwise to do it, that would be 153 degrees from north. Okay, all right. How about the bearing from O to C? So if we look from O to C here, all right, so from O to C on this side, right, if I look at it, from there, it will be again on the south side. And then if you look at it here to do some calculation, if I take 68 minus 90, this turns out to be 22. So it would be 22 degrees west. Now for this one, again, what would that degree be? From north clockwise, coming around here and be a little over 180 plus 22. And it should give me 202, okay, for the course. All right. So let's look down here quick and say, it says give the course of each ship and the bearing for each ship. So let's take a look at this quick. Notice that for each one of these, it starts on the north, all right? So we got north. Now in this case, if I was going to put it together, it would be north, right, 47 degrees east, okay, if I was going to write it that way. Now the course is, again, clockwise from here. So the course, just so you know, is 47 degrees. Now the bearing, okay, the bearing here, if you look at it this way, would be looking the other way here, right? So I would go through and try to figure out my way from there to the control tower. So it gives the course of each ship or airplane and its bearing to the lighthouse. Okay, so if I have that, what would be the bearing to the lighthouse? Again, I would come all the way around here. Okay, and I would get some version then of 270. Okay, for that. Okay, now for the next one here, if we go through here for the, it says give the course for each bearing ship or airplane. I'm not sure how much more we got to do, but that's sort of where we are at with that. Okay, let's get to some other problems here then. So number 3 says, if we sketch this, a boat is 58 miles south and 21 miles west of harbor. So let's try to look at this real quick here. All right. So first of all, 58 miles south. Do you agree that comes down like this? So some version of 58 miles this way. And then it's 21 miles west. So I don't know if you can see that's to the left. So this would be 21 miles this way. Okay, that would make this come down like this. Now, what bearing should the captain set to return to the harbor? Now, the other assumption here in this word problem is this is the harbor right there. So the starting point was the harbor. I am now here. I want to go there. So the thought now, what you have to do is you have to put a new outline there for this and try to figure it out. So if we're going to do this, then we have some trigonometry to do. Okay, because I think here I can figure out this angle. Okay, so how do I figure that angle? If you can see it, I think that's a tangent, right? If I would take the tangent inverse of opposite over adjacent, and you would put that in your calculator, that would come out and be, for that one, about 19.90 degrees. Okay, it's actually pretty precise. Okay, so if this right here is 19.90 degrees, then what bearing should I have? So again, going from here, because this is where I am, focus down here, what would it be? If that's 19.90, I don't know if you remember, do you remember your parallel lines? This here is also 19.90, okay, because of alternate interior angles. So what bearing should I set? It's on the north side. I would set it for north. 19.9 degrees, and again, because it goes to the right, it would be east. Okay, it's a little bit tricky there. Let's look at example 4 here quick then. Okay, for example 4, it says, you leave the entrance to a system of hiking trails and you hike 2.3 miles on a bearing of south 31 degrees west. All right, so what I got to do here is I got to start with a point. Start with it here is kind of the idea. Now, if I am hiking 2.3 miles, that's basically south. Here, I'll sketch this here. So south, I'm coming down this way, and then it's 31 degrees west. It's going to be on this side. So this is 31 degrees. And then what is the length of this? Again, if you can interpretate, that's 2.3 miles. Okay? Then it says, then the trail turns 90 degrees clockwise and you hike 3.5 miles at north. So I'm going to put another little, let me change my color here, I guess, quick. So if I change this to this, so now I'm resetting here again, and I'm going 90 degrees, okay, making a turn here, right? And you hike 3.5 miles on that bearing of north 59 degrees east, okay? So I'm going to head out this way, okay, where this overall angle is 90, but north 59 degrees west means that this right here is 59 degrees, if you can follow that. And this length is 3.5, and I end up here, okay? Now, the challenge here then, from there to there, all right, is if I want to look at this and try to see, first of all, how far from the entrance have you traveled? Well, that one's not too bad, because how do you find this with this 90? It's just Pythagorean theorem, right? So can you see the right triangle here? So to find this distance, which I do, okay, it would just be the square root of 3.5 squared plus 2.3 squared. And if you did that out, that would be 17.54. Okay? So if we have that, all right, I'm sorry, be square root of that. So then, I was going to say that's too big. Yeah, so about 4.2 miles, we're going to say. So now I have all of these distances, all right? Now it says, what is your bearing from the entrance to the trail system? So in order to find that, we need to go back here and try to find this angle right here, theta. Okay, now, how might we go about finding that? Now, what we do want to do is try to use the information that was given, not one that we found, all right? So that's just good analysis there. So I'm going to use tangent again, because what did I start off with, if you remember? I started off with the 3.5 and the 2.3. So what is that again? That would be tangent inverse of opposite over adjacent, right? And if I did that, that would give me some version of 56.69 degrees. Okay? Now, if that's the case there, how would I find out my bearing for this one? So if we look at that, if we take a look at it, this would be 31, okay, and this would be 56. Now, if you add those both together, can you see that that's less than 90? So actually my picture is not too accurate, because if I was to redraw the picture then a little bit to represent this theta, if this is 31 and I do another 56, I am on the south side, right? So 31 and 56.7-ish. Okay, I'm on that side. So if I want to know the bearing of that, how would that work again? Because my picture doesn't show it very good. I have to reanalyze it. It would be south, right? And then how far west? I would add these two together, right? And that would turn out to be 87.7, we'll say, west would be that answer. Okay? So, a lot of bearings there. Try to sketch that down. We'll do a couple other examples then with you. All right. Now, the rest of these I think are pretty simple to set up to start, and then we'll try some of the tougher ones. Let's look at example 5. Does this one make more sense? So the point above the ground is 80 feet above, 80 feet from the tower of the Eiffel Tower. So I'll put my Eiffel Tower here. I think this is a problem we're used to solving. So it's 80 feet from here. The angle of elevation from here to here is 85.4. Okay, and you want to get the height. So I think this one's a lot easier than the other ones in these applications, right? So we can pick up on this, but what would you do again? I have this, this, and this. What is that ratio? It would be a tangent ratio of 85.4 degrees, opposite over adjacent. Again, cross you know, divided by cross you don't. I would just multiply it. You would get some version of 994.31 feet. Okay. Now, what we can do here then for the rest of these, I think they're pretty straightforward. The rest of these have you set up some sort of angle and find the missing part, right, using a basic trig function for that. Let me just set up number 6, though, just to see if we can do that one, because it's a little bit tougher. This one says you're standing 800 feet from something, okay? Looking at a sculpture of Abraham Lincoln's face. The angle of the top elevation from to the bottom of the structure is 32 degrees. So this is the bottom of the structure that we're looking at. Okay, and then I look at the top of his top of his face, right, and it's up here at 35 degrees. Okay, so this one here, sorry, this one's 30 degrees. This one here is 35 degrees. And then what we could come up with here is basically the height of his face taking 2 measurements. So if we call this X and we call this Y, which are the easiest 2 to come up with, do you see to get this little height of his face, we can call it F. What would I do? I could find those 2 and subtract, if that makes sense. Now, these are both tangent functions, right? So if you can follow this, tangent of 30, or sorry, tangent of 32, lost track of that, okay, would equal X over 800, and then of course tangent of 35 would equal Y over 800. And if you would do those crosses, what you would get is you would get 560, well here, I'll write it over here so I can subtract it backward. You get 560.17 feet for that, and you would get 499.9, about basically 500 feet for that. So how could we figure out here from a distance now, something we couldn't measure on top of it but measure remotely, what would be the height of his face then if I would subtract these 2, right? So if I would take 560.17 minus 499.9, I would get that his face is about 60 if I round it off, I guess, 60.3 feet tall. Okay, so I did want to go over that. version where we have two sort of triangles here, two elevations made, and we could set it up. So what we're going to do when you come to class then is we'll expand on some of these. We'll look at bearings and courses, and then also go through some other applications to get started.